So Secchi transparency is one of the oldest and most widely adopted methods for measuring water clarity. A Secchi disc is a simple disc that is often bicolor, white and black, to make it visible in the water. The disc is lowered down through the water column until it disappears from view from an observer deploying the disc from the surface. The principle of Secchi measurement is that the limnologist that's making a measurement lowers a reflective disc down into the water column on a tape measure, which records how far the disc is from the surface. Light from the sun enters the water, reflects off the disc, and comes back to the eye of the observer. And the clearer the water, the deeper the disc. And the more turbid or highly productive the water, the shallower the disc. And so the depth of a Secchi disc measurement gives us a very good estimate of water clarity. And for a given lake, changes in Secchi transparency correlate very well to changes in biomass or plankton abundance. In main lakes, a really clear lake will have a Secchi transparency of 10 meters, and a really impacted lake will have a Secchi transparency of a half a meter. And that means that there's enough, usually plants or algae growing in the lake, that you wouldn't be able to see your feet if you were wading knee-deep in the water. In our work, we have been taking advantage of 40 years of Secchi transparency measurements to understand the changes in the water quality of the lakes, particularly the water quality of the Belgrade lakes. And what we've observed is a gradual decline in Secchi transparency in all of our lakes. In our cleaner lakes, the transparency's gone from about 6 meters down to 5 or 4.5 meters in depth. And in some of our impacted lakes, the transparency's gone from 4.5 to 5 meters to less than half a meter in depth. So we are using Secchi transparency to understand how the long-term water quality has changed on an annual basis, and also to understand how the water quality is changing over the course of the summer.
Long-term, Secchi transparencies can signal changes in lake ecology. The addition of nutrients over decades promotes algal growth, resulting in a decrease in visibility in the lakes. Using Great Pond as an example, you'll note a slow and steady increase. Secchi depth is still very good, and the change is not noticeable to most recreational lake users. Long-term trend analysis, such as this, is appropriate if the lake is stable. However, averages and trend analysis don't always tell the full story. Let's look at East Pond. Over 40 years, the average trend has shown a decrease of 1 meter. However, there is significant oscillation throughout the season. Blooms in the spring are the result of winter nutrients. A clear phase in the early summer is a result of nutrient limitation. Blooms in late summer result from a release of nutrients from the sediments. East Pond reaches a tipping point each summer in early August. Let's contrast this with Great Pond. Over the last 40 years, Great Pond has shown a similar 1 meter decrease in Secchi. However, it has yet to reach a tipping point. We never want to let any of the other lakes in the Belgrades reach a tipping point. Secchi is one tool that helps us keep close tabs on the ecological health of the Belgrade lakes.